Example number 2, pretty similar, but we have a little bit different information. We're asked to find the standard form of the equation of the ellipse having the vertices at 2, 0 and 2, 8, and foci at 2, 3 and 2, 5. So let's just quickly draw this out. Now, before we even get to that, looking at these four coordinates, so all four of these, the vertices and the foci, are going to be all in the same line. You'll notice they all have the same x-coordinate of 2, which means that they're all going to be on a vertical line, so we're going to be dealing with a vertical major axis. So, drawing this out, we're going to go 2 over, and it looks like the highest we have to go up is 8, so we'll go 1, 2, 3, 4, 5, 6, 7, 8. I know it's not perfectly spaced, but that's okay. So, we have a point at 2, 0. That's one of our vertices. We have a point at 2, 8. That's another vertex. Then we have foci at 2, 3. So we have 2, 3, and 2, 5. So the focus. Okay, let's start off just by talking about the major axis length. The major axis length is the distance from vertex to vertex. In this case, it's just 8. And remember, the whole length of the the whole length of the major axis is 2 times the a value, which means our a value is going to be 4. We'll come back to that in a little bit. Now, the center is another thing we can fairly easily find because, well, it's central to everything. So along this, it's going to be halfway between your foci, halfway between your vertices. Our center is right there at 2, 4. Now, the other part we need is we're going to need the C value, which is the distance from the focus, from either focus to the center, and that's just the distance of 1. So we can use that information to find the B value that we're going to need for our equation. So we got C squared equals A squared minus B squared. So again, not quite the Pythagorean theorem. Our C squared, we got 1 squared. A, we ended up figuring out was 4, so we got 4 squared equals, minus B squared. We got 1 equals 16 minus B squared. And then we're going to subtract 16 from both sides. We end up with negative 15 equals negative b squared, which, shortcut, we got 15 equals positive b squared. We got to take the square root of both sides, and we end up with the square root of 15 equals b. Again, that always kind of seems like a pain in the butt until you remember b is going to get squared later. So what we're going to end up having here, this is a vertical major axis. So we have a vertical major axis. So we're dealing with the equation x minus h squared over b squared plus y minus k squared over a squared equals 1. Now, I didn't label h and k yet, but remember, those come from the vertex. So that's, not the vertex, the center. So the h and k are the x and y coordinates of our center. So we have x minus the h value was 2 squared over b squared. Well, we already know what b is. B is the square root of 15. Well, actually, I'll write it out. So we got the square root of 15, and that's being squared, plus y minus k squared over our a value, which was 4 squared, equals 1. Cleaning it up, 15, or the square root of 15 squared is just 15. So that first fraction, we end up with x minus 2 over 15 plus y minus, oh my goodness, I didn't even replace the k value in the previous line. My apologies. Our k value, again, that's the 4, so we have y minus 4 squared over 4 squared is 16 equals 1. So that is the equation for this line. Now, one thing we didn't do in the previous example is I didn't have us do anything with the minor axis. That's partially because, well, the minor axis in this case is kind of annoying because it's the square root of 15 times 2. That's going to be kind of hard to draw, so we're skipping that for now.